gravitation. Now we are to the end of this chapter and the last topic left, that is mass and weight. So today we discuss about the term mass and weight. So in the previous class, hope you have gone through the video. Okay, in the previous class I explained you about the term force due to gravity, acceleration due to gravity, value of acceleration due to gravity, when the acceleration due to gravity or the value of acceleration due to gravity becomes negative and positive. Okay, and how the equation becomes negative and positive. All these things I have explained in the previous class. Now today we will come to the term mass and weight. And this term we have been studying since from class 6 onwards. These are very easy to understand. And this mass means the quantity of matter contained in a body. Quantity of matter contained in a body. Which means now matter is, now what is matter actually? Matter is anything which has mass and occupies space. Any object which has got mass, when they occupy space, they are considered as mass. Sorry, they are considered as the matter. And matter is the body which has got mass and occupies space. And mass is the body in which has matter contained in it. Mass is the body, okay, in which the matter is present in that body. That means the body which has got mass and occupies space, they are known as the matter, okay. And any object or any body which has got matter, that we call it as a mass. So therefore, mass is the quantity of matter contained in a body. So the SI unit of mass is kilogram and the CGS unit of mass is gram. And the mass of a body remains constant wherever it is taken to any place on the earth's surface. Wherever you take the body to any place on the earth's surface, the mass of the body always remains constant. They will not change. Okay? And the mass is measured by instrument known as physical balance or the beam balance. Physical balance or the beam balance is an instrument to measure the mass of the body. Second one is the weight. The weight of a body is the force. Actually, the weight is the force. Weight of a body is the force which are attracted by the Earth's gravity. It is the force which are attracted by the Earth's gravity. So always now this weight and force, they are related. Weight is equals to force because weight is the force, okay, which are attracted by the Earth's gravity. So therefore, now when we see the relation between the weight and the force, we know that force equals to mass into acceleration. You know that F equals to m into a. According to the definition of force, force equals to mass into acceleration. But weight of a body is also the force. So instead of force, I can write here W. Weight of the body is the force which are attracted by the Earth's gravity. That is, which are attracted by the Earth's gravity. So instead of acceleration, what I can write here? Acceleration due to gravity. So W equals to m into g. So this is the relation of weight. Okay, to find weight, to calculate weight, you use the relation W equals to m into g. Now why I am writing W equals to m into g? Because the weight is the force. It is a force which are attracted by the Earth's gravity, and since we can write force equals to m into a, so W also we can write m into, instead of a I am writing g, because these are attracted, this weight of the body is attracted by the Earth's gravity. Okay, and this is attracted by the Earth's gravity, which we call it as acceleration due to gravity. So therefore instead of a I can write it here small letter g. And this W equals to m into g also gives the relation between the mass and the weight. This equation W equals to m into g will give the relation between the mass and the weight. So W equals to m into z I can write here, or what I can write here, m into z equals to W, or m equals to W divided by z. Okay, so to calculate mass, weight of the body divided by acceleration due to gravity. To calculate weight, mass of the body multiplied by acceleration due to gravity. So this relation gives the relation between the mass and the weight. And the weight of the SI unit of weight is same as that of SI unit of force. The SI unit of weight is Newton. The SI unit of weight is Newton. The CGS unit of weight is dyne. It is same as that of force because the SI unit of force is also Newton. The CGS unit of force is also dyne. Similarly, the SI unit of and the CGS unit of weight will also remain same. Since weight is the force. And weight is measured by an instrument known as the spring balance. Spring balance is an instrument to measure the weight of the body. Now, when we see the difference between the mass and the weight, mass is the matter contained in the body. Weight is the force attracted by the Earth's gravity. Mass of the body remains same wherever it is taken to any place on the Earth's surface. Weight of the body changes. Weight of the body changes when they are taken to different places on the Earth's surface. Okay? And this weight of the body will change due to the change in the value of acceleration due to gravity. Because the value of acceleration due to gravity on the Earth's surface is 9.8 meter per second square. But this 9.8 meter per second square can be changed when the body is taken to different places on the Earth's surface. So therefore, due to the change in the value of acceleration due to gravity, the weight of the body will also change. Okay? And the weight of the body is measured by an instrument known as the spring balance. Now the next point is gravitational unit of weight. Now the gravitational unit of, when we come to the gravitational unit of force, the gravitational unit, the SI unit of gravitational unit of force is kilogram force, kgf, and the CGS unit is gram force. Okay? Kilogram force and gram force is the gravitational unit of force. And 1 kilogram force is equals to 9.8 Newton. 1 gram force equals to 980 dyne. Okay, so this is the relation which I have already explained you in the offline classes also. 1 kilogram force equals to 9.8 Newton and 1 gram force is equals to 980 dyne. So these are the gravitational unit of force. Okay, and this gravitational unit of force is equivalent to gravitational unit of weight. And gravitational unit of weight is also 1 kilogram force equals to 9.8 Newton and 1 gram force equals to 980 dyne. So this is about the mass and weight of the body. Okay, in the next class we will start with a new chapter, pressure in fluids and atmospheric